Okay, so let's kind of see. Um, okay, so they want to know what N1 is. So now they make these, much more harder problem. We have to know what is the formula. So we just did these a moment ago in the previous video, if we saw the previous two videos. So we already know this here. It is true that this is going to be what? This is a test statistic Z. Test statistic Z is going to equal, this is going to be test statistic Z, or this is actually going to be margin of error E is going to equal Z star. Yeah, P bar Q bar 1 over N1 plus P2 Q2 bar over N2. Yeah, that's a Z star there. So we can kind of read the thing here. Yeah, we have all that. N1. Okay, good. So we have all of this. I thought they were going to have us solve an equation. They literally just want us to plug everything in from what's given there. We see all of it there. Let's go ahead and do all that. Yeah, so a large clinical trial were randomly assigned to two groups. The treatment group, 193, 604. Okay, good. So P hat 1 is X1 over N1. Yeah. The treatment group children, yeah, so that and 25 of those develop, so it has to be 25 divided by that number is P1 hat. I'm doing 25 divided by 193, 604, and I get, they want us to go 8 decimals here, so sometimes they just do some trippy stuff. That's 3, 4, 5, 6, 7, 8 is what I get. So Q1 is literally 1 minus that answer. That's what that is. More than likely also to 8 decimals. So 0.999871. That's what I get. Just be careful. So it's Q1. This is a mistake, but they need 8 decimals, don't they? 0.9998787. I don't know why I chose to stop there. Yep, and Q2 is going to be 197,389. Yeah, that's P2 there. Let's calculate that. That's going to be 96 divided by the number, right? Divided by 197,389. Also to 8 decimals, I get 0.0004865. So we have P2, that's P1 hat, Q1 hat, P2 hat, Q2 hat is going to be 1 minus that. So we get 0.999,51365. Okay, so P bar is going to be x1 plus x2 over n1 plus n2. So 25 plus 96 divided by 390, 993. Yep, that's all of it there. I get 0.0003097, and that's 1 minus the answer. Okay, so finally we're doing the hypothesis test here. Sometimes they just want us to do the null, but the null is always an equal to, by the way. It cannot be, uh, the null is HO. We haven't talked about this much, but we cannot have a not equal to, we cannot have a greater than, we cannot have that. The first one, the H0, the null, has to be an equal sign, but the alternative can be less than, greater than, or not equal to, and it will give us this. So a newspaper published an article about a study in which researchers subjected laboratory gloves to stress. Among this many gloves, blah, blah, blah. They tell us the data collection. Using the accompanying display of technology results, use this significance level, test the claim that the vinyl gloves have a greater virus leak than the latex. That's P1 is greater than P2. That's what that is. Unless, of course, they swap it, but we got it right. So the test statistic, what we're going to start doing is we're going to start plugging this stuff into the calculators. What we're going to start doing. So if we do stat test, no, it is stat, button on our calculator, scroll to the right to test. It's going to be a list of all of our confidence intervals and a hypothesis test. This is a 2-prop z-test, the difference between two proportion tests. Yeah, I have it as number 6, a 2-prop z-test. 2-prop z-test. And it'll give us everything here. So we press enter on that, and we literally just want to plug everything in. So what I'm plugging in is x1, n1, x2, n2, and then we have to plug in a greater than for the alternative hypothesis. But all we have to plug in is x1, x2, n1, n2. All the calculations come from that. So usually it's respective. Sometimes we have to read it closely, but usually, you know, P1 is the first thing mentioned, P2 is the second thing mentioned. But N1, I see 2, 1, 2. We run into a problem. It's not really a problem, but we have P hat 1 and 2 equals x1 over n1. Yeah. If we're given, because we need x1, if we're given that, then we have to multiply them. That's a 1. Then we have to multiply them to get x1. So we have to multiply 2, 1, 2 times 0.55 and make it an integer, so approximately 117. So I'm literally doing is 117, 212. The n2 is also 212, and then it's 212 times 0.08, and that's what? So what we get here, we get the readout, and the readout is going to be a z. Let's just test this because sometimes you get an extreme one. 10.45 is extremely high. They're usually between plus or minus 3 is where they usually are. But before we move forward, let's test that, make sure there's no mistake there. Every now and again, you get an exceptionally high test statistic, which does mean we'd have a p-value of 0. That's wrong though anyways. But what happened to the test? Make sure we did this right here. 2 prop z test. We have the right, yeah, p1 is greater than p2. Among 212 vinyl gloves, 55%. Among 212 latex gloves, 8%. $17. P1 greater than P2, rounded 2 decimal places. 10.45. What the heck did I do there? That was stupid. Okay, so it turns out it was correct anyways. My bad. Yeah, so if we have such an extreme thing, but this is basically what we get. We get 2 main things. We get the test statistic and we get the p-value. To reject the null hypothesis, we're looking for as small a p-value as possible. So if we have such an extreme test stat, it means we have a p of 0. Yeah. So in the end, we want the p-value. We want the p-value to be less than or equal to alpha, which is 0.01. The p-value is 0, so it is less than or equal to alpha. That's what we want though right there. So we have to have the p-value is less than significance level, so reject the null. There is insufficient evidence. Sorry. There's sufficient evidence. And then if we read that, that's what they're going for on that one. So now we're conducting the full hypothesis test. So we can kind of skim, use 0.05 significance level, test the claim that men and women have equal successes in challenging. That means the null has an equal sign. No, that means, yeah, the null has an equal sign, but the alternative has a not equal sign. There's only 3 for the alternative, less than, greater than, or not equal to. If they don't tell us less than or greater than, it's automatically not equal to. So now what we have to do is we have to put all that stuff in the calculator, same exact test as before. Okay, so if we do this, we do the test on our calculator, I get a z, which is the test statistic, is 0.38, which means a fairly large p. The p-value, yeah, is going to equal 0.7017. What is the alpha? 0.05. So this is greater than alpha, which means don't reject the null, right? It's greater than alpha equals 0.05. Three decimal places is fine, 0.702. Okay, good. So the p-value for this one, the p-value is greater than the significance level alpha. So fail to reject the null. Usually yep. Fail to reject the null, yeah. So usually with this thing here, the significance level of that fail to reject the null, that should usually mean if we read it, there's not sufficient. It's easy to kind of read it clearly after you do the thing. Yeah. Okay, so now they want us to do the 95% confidence interval, which is just plug it into the difference between two proportions interval. Yeah, 2 prop z int is what that is. We plug in all the same stuff with 95% confidence. If you just go to it on your calculator, usually it's already plugged in. 0.0325, 0.048. What the heck am I doing here? I'm not even paying attention to this. 0.033 and 0.048. Correct. Pause the video for just 1 wee second here. Not too sure if we can hear, but I just feel like doing this video with some Scarlatti. So also in the background, I am listening to Domenico Scarlatti, which is of the late Baroque. I think Bach died in 1750, Scarlatti in like 1757 or something. But Domenico Scarlatti, definitely one of my favorite composers. So Scarlatti Piano Sonatas in the background. Okay, so let's do this here. If the interval contains 0, that means we don't have enough evidence to reject the null. It does not. It does include 0. Yeah. There does not appear to be a significant difference. Based on the results, does it appear that men and women have equal success in challenging calls? The answer is yes, because we didn't find it significantly different from 0, both the hypothesis test and confidence interval. I never really like reading these things. So what is the answer here? Which of the following is not true? Of confidence interval estimates the difference between two population proportions. The confidence interval uses a standard. Yeah, so the correct answer is what? It's going to be C. A confidence interval is used to test a claim about two population proportions. These can be a little bit confusing. I don't think it's too important. We don't really need a description. Correct answer is D, which would be these samples are independent because there's not a natural pairing between two samples. Okay, so they always say it in their use 0.056 confidence level to test the claim that the given candy does result in greater tips. Are we to say that mu1 is greater than mu2 or the opposite? Yeah, mu2 is the tip, so it'd be mu1 less than mu2. Okay. And then we can simply take that data in the upper right and put it in a difference. It is a difference between two means. independent sample, and it is a t distribution because they have S. Two sample t-test is what it is. And then we input all that. And don't forget to put the alternative is less than. Pooled is usually no.
Squarespace's creative tools let you design a unique, engaging website.
So I get the test statistic is negative 4 point. So the test statistic and the p-value are the two most important things. And the readout will just spit all that out. I get 0.000, I think. I get 0. It's a very strong P. It means we very obviously reject the null. So it's always a little bit difficult with the hypothesis test. I mean, the confidence interval, because they have to give us a confidence. What they want to do, they only assign it sometimes, honestly, so it can be a struggle. But they want us to use the alpha, which is 0.05, to do the confidence. The thing is, like, we never know if we multiply it by 2. Confidence intervals are always two-tailed. This hypothesis test is one-tailed because it's less than. So, you know, we can try 90%, which means the alpha is times 2 is 0.1, or we can try 95. I'm just going to try 95% confidence. And there's always good news because all of our previous stuff that we typed in for the test is already in there. So we do a 2 sample t int. I'm just trusting that all my stuff is still in there. I'm going to say 95% confidence. And then we have to know for a test or quiz, but we just, you know, we give this a try here. It's a little bit harder to do the theory, I think, for that. Round to 2 decimal places. Negative 3.23. Negative 1.27. So they say nay. They say nay. Round to 2 decimal places as needed. Yeah, they give us all that stuff there. If it's one-tailed, I'm thinking we might have to multiply that by 2, which would be alpha's 0.1, so the confidence is 0.9. The confidence might be 90. Let's try that. If we try that, I get negative, round to 2 decimal places. Yeah, negative 3.07. Negative 1.43. Okay, good. So yeah, we did have to multiply the confidence by 2. I think if it's two-tailed, not equal to, then you don't. But if it's left-tailed or right-tailed, then we have to multiply the alpha by 2. So only negative values means there is evidence that the means are different, that there's evidence of the alternative that mu1 is less than mu2, or mu2 with the tips is greater than mu1. Okay, so a lot of this stuff is kind of coming to kind of this is the end tail of the class. You know, some probability and statistics, we'll do hypothesis tests at the end of the class. It's one of the hardest parts. And it's so hard, some of them will make it the entire last half of the class. So not necessarily the end. Okay, so this is not easy to do. I'm going to say list 1. And I'm going to say list 2. And of course, we do them in columns. And what we do is we do list 3 equals list 1 minus list 2. You just subtract straight across or straight down, if that makes sense. And we get a difference in values. This is the mean of list 3. This is the mean of differences. It's not the difference of means, it's the mean of differences. So what we actually do here is we do L1, L2. Usually that don't trick us in the order. We subtract straight across so that we have L3. Then I'm going to do a single t-test with L3, and all of it comes out. The D bar, the SD, all of it comes out. And what is this? This is a hypothesis test for two dependent samples, and it's the mean of differences is what that is, that mu D. We're trying to estimate the mean of differences. Yeah. So let's see if I can do that. Currently typing them into a list.
Don't get burned choosing your credit book. See if you're pre-approved in 3 simple steps with no.
Making a YouTube video while listening to YouTube. Okay, so Domenico Scarlatti Piano Sonatas. If you subscribe to my channel, I will give you over time a large collection of classical music. So I know a lot of the great stuff from the classical period, before that into the late Baroque, and after that into the Romantic, but I can make an entire giant YouTube channel based only on classical music. Okay, so we do L1, L2, then we do L1 minus L2 is L3. And then what I'm going is I'm going to test number 2, which is simply t-test. So when you go to a test, usually this is t-test. Usually you have a data or you have stats. Yeah, so stats is if we're not using a list. If we're ever using a list, we have to go scroll over to data, and then we can just input a list. The null for this one is always 0. The input is always 0 for the little mu. You always put a 0. For the list that we put in there, we have to put L3. Okay, so we do have to look for the hypothesis test. Let temperature, blah, blah, blah. So listed below are body temperatures for the 5. Oh, silly me, so I'm doing all this. I'm just kind of going through all this. They might not even ask us. They might just tell us to find mu D. Although the hypothesis test also gives us mu D, which is a negative 0.44. And SD, I got 0.45. Okay, so this time we actually have to do the thing. So it's always going to be 0 and 0. Okay, good, good, good. So I'm kind of thinking if this video is kind of running a little bit far here, I think we're going to put we're going to start this difference between two means dependent samples. We're going to put it in the next video.